What's up, guys? It's Meg Talks Science here. I'm Meg, I talk about science, and today I'm going to be discussing the myth that our brains don't fully mature until we're 25. So, let's get started.
At the age of 25, we've pretty much, set in our ways with our brain. Our brain is not developing, it's fully developed at around 25 years old.
Nice.
Okay, now that you've seen those TikToks, let's get one thing straight. You are not a casserole, okay? You're not just fully cooked once a timer goes off. That is not how time works. That's not how aging works. That's not how neuroscience works. It makes no sense. And honestly, the reason I want to make this video is that thought process isn't just limited to TikTok. So the Supreme Court case Roper v. Simmons, which is where they decided that adolescents or people under the age of 18 should not have the death penalty applied to them, used the same kind of neuroscience philosophy in their decision-making process. And while I think that they landed on a good decision, I think that overall, this myth has possibly done more harm to society than good. You see, it helps infantilize anyone under the age of 25 while simultaneously perpetuating the idea that once you're past 25, you're just fully cooked and you can't change or learn or grow anymore. And I think that both of those ideas are actually really harmful. So, what does the neuroscience say? Are we like trees in that you can count our rings or our years of experience, and then as soon as we get to a certain point, you can call us mature? Or is there a bit more squishiness around it? As a side note, when I do get into the science, which is in just a second, I will put up all my sources on the screen, and then I'll link everything that I talk about in the description below so that if you're interested, you can check it out. So, let's get started. So the first question that we have to ask if we're going to bust this myth is what a mature brain would even look like and how it grows. So the thing about brains is that we don't really grow like our height does. So with height, it follows a fairly linear growth curve. You basically grow up to a certain point and then you stop growing. With brains, it's a bit different. In your childhood, you make a lot of new connections and you see a lot of actual brain growth. But eventually, you start having to prune those connections to make room for more important ones, and you do see your brain start to decrease in size. And it's that pruning that will eventually start to kind of level off, and you'll reach a certain level where your brain will more or less stay the same at a certain point. But the question is, when is that point reached? It's a bit harder to answer than just when do you reach your maximum height, because you have to follow someone, ideally, through when their connections increase and also decrease again, and then see how long it'll stay there. So, what does the science actually say? So, what do we see in those long-term and really big neuroscience studies that actually talk about when the brain matures? Now, because it is neuroscience and neuroscience gets a bit complicated, it turns out that this question can have different answers depending on how you look at it. So, if you just look at total volume of the brain, just total volume of what's going on up there, then you'll find that that tends to start leveling off or stop changing about when you're 30, which is still a lot older than our original timeline of the brain maturing at 25. So myth busted, right? Well, it gets a little bit more complicated than that. You see, when you start looking at individual structures of the brain, especially the frontal lobe, which is associated with things like executive planning and decision making, you tend to see that depending on how you look at it, it could stop developing somewhere between 25 and 30. So that's still past our original 25-year cutoff date, but it does lend a bit of weight to that whole idea. However, other structures in the brain, important structures in the brain, can mature, until you're 40. So those things are just changing around up there. Furthermore, it's not just the individual structures that you have to think about. Sometimes it's how well connected those structures are. So another study measured myelination of the cortex, which is how well connected neurons are, how fast the transmission speed is, and how leaky they are. And myelination improves and continues getting better well into your 30s. The oldest participant for this study was 35, and they just found it going. So even if your brain stops changing structures, it can still increase its connections a lot, which means that your brain is still fully ready to learn and grow well past the age of 25. So yeah, I do think that that's completely a myth. So to recap what I just said with fewer visual aids to make it a little bit less confusing, there are quite a few ways to measure maturity in your brain, like we just talked about, but many of them don't stop growing or changing until you're well into your 30s or even 40. So I think that that's enough to discount that little myth that your brain doesn't mature until you're 25. It actually takes you a long time to stop changing or growing. And even when you are an adult, you are fully capable of learning and changing. Not to mention, there are so many individual differences that make it really hard to just decide a perfect time when you're perfectly developed. So one study identified that socioeconomic status and peer acceptance, or how well you feel accepted by your friends, can influence later brain development. There was a different study that compared brains as they aged to kind of see if they could look and identify a brain's age just by a scan of it. And while for the most part you can make conclusions about that, they also found some 8-year-old brains that looked a lot older than 25-year-old brains. So it's very much up to individual development. I think this makes the myth even sillier because, of course, you can't just choose a magic number like 25 and say that everyone's perfectly developed by then. That makes no sense. So does that mean that we should just move our magic age up and say that, oh, everyone's definitely developed by age 40? And my answer to that is no, not at all. Once you're an adult, you still have lots of ways to learn and grow. So you've probably heard of neuroplasticity, or the brain's ability to learn and form new connections, and that doesn't just go away when you turn 40. We've also seen adult neurogenesis, which means that even as an adult, you are making new neurons. So you don't just stagnate as a person once your brain stops going through all these crazy structural changes. And part of the reason that it does all that pruning to begin with is so that you can focus on important things. It's not like you just lose random stuff. And while brains will eventually atrophy, especially in the 80 plus age range, I don't want to discount the importance of that. You have a long time to learn and grow and do things. Your life doesn't end when you turn 25 or 40. You can still grow. It's part of being human. So what about the flip side of that? Does that mean that everyone who's under the age of 25 or 40 is just a baby or a child and can't make decisions? And the answer to that is, of course, no. So let's take it all the way back to adolescence. When you're an adolescent, your brain is not broken. That stage exists for a reason. You're experiencing all these adolescent behaviors like sensation-seeking, risk-taking, wanting independence, because that teaches you and drives you forward into being an independent adult. So especially once you are 18 and you have gone through that adolescent phase, you're now going to start transitioning probably out of those adolescent behaviors. But throughout that whole time, you're still capable of thinking, okay? You're still a living, breathing, thinking person. That doesn't change just because you're in a period of growth. When you are, an adult, when you're 40 or 50, you might look back on those times and think, oh man, I made some really dumb decisions. But it was still a stage of growth and learning for you. You probably learned valuable things during that time. Overall, this means that even if your brain isn't fully set in how it's going to be, you can still make decisions and you can still make good decisions. It's just a period of learning and growth. That's it. Okay, so what did we learn from all this? Or at least what did I hope that you took away from it? I hope you know that maturity of the brain has a few different ways that you can measure it, but a lot of them end up looking like we keep maturing way past that 25-year myth that we've heard of, and that we can even keep having our brain structures change into our 40s. So please know that now. However, once your brain is finished changing in those structures, there are still plenty of ways to learn and grow and develop as you go on in life. And the flip side of that is also true. So just because you're not done with your brain changing doesn't mean that you can't make decisions, or especially if you're over the age of 18, that you're not an adult. I would say the metaphor that I like is that the house is built and the house is ready to live in. Sometimes you just got to change the furnishings, make different decisions and grow over time. Also, please just stop looking at TikTok for science information. It's not helpful. It's not good for us, and it's going to kill me. So yeah, stop. So that brings us to part 2 of this video. Where did this myth actually come from? So guys, here's my confession. I have a disease, an illness even, and that illness is curiosity. After I finished doing all the research for debunking the myth, I just could not get it out of my head of where this even came from, because it was so easy to debunk. So who thought of this in the first place? And honestly, this took me on a journey that had me feeling crazier than when I started. So the first place that I ended up in my little Google rabbit hole was this Slate article that came out in 2022 that told me that the neuroscience community also doesn't know where this myth came from. So I will read to you the relevant quotes. So Larry Steinberg is a giant in the field of adolescent development, well known for his 4 decades of research on adolescent and young adults. When asked, he said, "There's consensus among neuroscientists that brain development continues into the 20s, but there's far from any consensus about any specific age that defines the boundary between adolescent and adulthood. I honestly don't know why people picked 25, he said. It's a nice sounding number. It's divisible by 5. Kate Mills, a developmental neuroscientist at the University of Oregon, was equally puzzled. That is funny to me. I don't know why 25, Mills said. We're still not there with research to really say that the brain is mature at 25 because we still don't have a good indication of what maturity even looks like. So then I started to think, wait a minute, what actually tipped me off that this was a myth to begin with? And that was, drumroll please, a random unsourced Reddit comment on the internet. I read it and then I was like, oh wait, that makes sense, because I have a bachelor's degree and a master's degree in neuroscience. So sometimes when you read something like that, it just makes you think just enough to actually realize that something is a myth, which was what happened for me. That led to lots of unsuccessful Google searches with the name Reddit at the end to try to figure this out. And while I couldn't find the comment that tipped me off, I do think that I found the Tumblr post that comment got its information from. So I will read aloud that for you. Okay, this is long. Oh God, what did I do? The brain isn't fully mature until age 25 bit is actually a fairly impressive bit of pseudoscience for how incredibly stupid the way it misinterprets the data it's based on is. Okay, so there's a part of the brain called the prefrontal cortex, which is, among other things, responsible for executive function and impulse control. Like most parts of the brain, it undergoes active rewiring over time, i.e. pruning unused neural connections and establishing new ones. And in the case of the prefrontal cortex in particular, this rewiring sharply accelerates during puberty. All that, actually, is true. Because the pace of rewiring in the prefrontal cortex is linked to specific developmental milestones, it was hypothesized that it would slow down and eventually stop in adulthood. However, the process can't directly be observed. The only way to show how much neural rewiring is taking place in a particular part of the brain is to compare multiple brain scans of the same individual performed over a period of time. Thus, something called a longitudinal study was commissioned. The same individuals would undergo regular brain scans over a period of many years, beginning in early childhood, so that their prefrontal development could accurately be tracked. The longitudinal study was originally planned to follow its subjects up to age 21. However, when the predicted cessation of the prefrontal wiring was not observed by age 21, additional funding was obtained, and the study was extended to age 25. The predicted cessation of prefrontal development wasn't observed by age 25 either, at which point the study was terminated. When the mainstream press got a hold of these results, the conclusion that prefrontal rewiring continues at least until age 25 was reported as prefrontal development finishing at age 25. Critically, this is the exact opposite of what the study actually concluded. The study was unable to identify a stopping point for prefrontal development because no such stopping point was observed for any subjects during the study period. The only significance of the age 25 is that no subjects were tracked beyond this age because the study ran out of funding. It gets me when people try to argue against the neuroscience proves everybody under 25 is a child talking point by claiming that it's merely an average or that prefrontal development doesn't tell the whole story. Like, no, it's not an average. It's just bullshit. There's no evidence that the cited phenomenon exists at all. If there is an age where prefrontal wiring levels off and stops, and it's not clear that there is, we don't know what age that is. We merely know that it must be older than 25. So unfortunately for me, this long Tumblr post has no sources whatsoever and does not name any specific studies. Fortunately for me, the users of the subreddit r/curated Tumblr were equally as interested as I was. And one user, Snake for Legs, directed me down the path of looking at the work of Jay Geed. So his comment says, the study is Goktae Geed et al., Dynamic Mapping of Human Cortical Development During Childhood Through Early Adulthood. Fortunately, the user also gives a PubMed link of the study, and then also links a news story that was reporting on the study. Also, as a bit of a side note, I went looking so hard to find any mention of that study or the longitudinal study at all running out of funding, and I can't find that anywhere online. It's not uncommon for researchers to want to continue something like that and then the funding just isn't there. So it's possible that it's true, but it's also entirely possible that that is just a myth created while debunking another myth, which is my favorite kind of myth. So from there, I decided to get into Dr. Geed's research myself and see if there was anything I could find that would point me to these longitudinal studies that were supposed to be there showing me brain development and how it changes. Fortunately, this was fairly easy because those are a couple of his most cited papers. And this was a green flag for me in terms of this being possibly the origin of the myth, because a well-cited paper is going to have been read by a lot more people than a less cited paper. And this means that it has a quite high probability of having broken containment and it no longer just being in academia anymore, which seems to be exactly what happened here. So what did these studies say? The first, which was released in 1999, did indeed have participants ranging from age 4 to 21, and it did follow how the brain changed as it grows. So that's pretty promising. The second, which was released in 2004, also had a similar age range as the first study, though. So that one had, I think the oldest participant was 22 in it. However, this was the same study that was linked by the Reddit user Snake for Legs, which said that this was definitely the origin of the myth. But there was a third installment of this longitudinal study that came out in 2015. And this was the first one I could find with any participants that were at least 25 years of age. And specific parts of the brain were continuing to develop at that age. So, cool. I have now narrowed it down to two possible sources, the 2004 paper and the 2015 paper. I think the Tumblr post would have suggested that it would be the 2015 paper because the Tumblr post said that the participants were at least 25. Reddit user Snake for Legs narrowed it down to the 2004 paper. So let's check out any kind of articles around either of them and see what they say. So that led me to the NBC article that Reddit user Snake for Legs had posted. So that one came from 2004, and it was called Brain Immaturity Can Be Deadly, and it was an article about teenage driving. It was making the argument that teen brains just aren't really developed enough to drive that well. So the little blurb says, by most physical measures, teenagers should be the world's best drivers. Their muscles are supple, their reflexes quick, their senses at a lifetime peak. Yet, car crashes kill more of them than any other cause. A problem some researchers believe that is rooted in the adolescent brain. And would you believe they managed to get a quote from Dr. Jay Geed about the dangers of adolescent driving? Okay, sure, whatever. So Geed was saying, we thought the highest levels of physical and brain maturity were reached by 18, maybe earlier, so this threw us, says Jay Geed, a pediatric psychiatrist leading the study, which released its first results in April. This makes adolescence a dangerous time when it should be the best. Okay, this makes sense. But just before Dr. Geed's quote, we have this little block of text. While society and tradition have placed the point of intellectual maturity, or the age of reason, years earlier, this study, an international effort led by the NIH's Institute of Mental Health and UCLA's Laboratory of Neuroimaging, shows it comes at about age 25. So there it is. There's the number. There is the magic 25 number, and it appears in 2005. But where did we get that? Dr. Geed's participants are not that old. At this time, they're probably around 19 or 20, maybe 21. And this clearly comes out of his research because it's right before his quote. But the number itself isn't a direct quote either. It's just a statement. So here's this myth that I'm tracking, but what study did it come out of? So I go back to Google. I'm just looking for any kind of other article that might tell me a little bit more about what Dr. Geed was saying in interviews at this time. And that leads me to a 2004 piece with an interview with Dr. Geed that was about his most recent study, so the 2004 study. And it's a science piece, right? It's published, I think, with the APA, with the American Psychological Association. So it's called Brain Research Advances Help Elucidate Teen Behavior. It's just a little piece about new research coming from Geed's group. What can it say? Surely there wouldn't be a piece of blatant misinformation in like a scientific piece of writing. Oh God, no. No, really? Okay, here's the quote, you guys. The research also shows that brains don't fully develop until age 25. And then it goes on. And that teenagers tend to depend on the part of the brain that mediates fear and other gut reactions, or the amygdala, when making decisions, he said. He being Dr. Geed himself. That's important information for attorneys and judges to consider as they work with children in the legal system, he added. And guys, there it is. That's the earliest text I can find that says that the brain matures at 25. It's from an interview, a piece of science communication, really, with an indirect quote from Dr. Geed himself. And it's buried in some other text. It is completely likely that Dr. Geed used some other words in both this article and the teen driving article. The 25 number isn't a direct quote. So it's likely that Dr. Geed used the kind of language that scientists tend to use. He probably said, we don't know for sure, that more research needs to be completed, that their longitudinal study isn't even done, but that maybe the human brain shouldn't be considered mature until at least 25. Maybe. Hilariously, it's also possible that that little nugget of information was reinforced by the graphs in the 2004 piece. So in Geed 2004, there's at the very beginning, there's a graph that has an axis that just ends at age 25. So is that it? Is it just a misread graph and maybe a half-remembered conversation? Did that spark this myth that has been haunting me? Is that it? And honestly, no, I don't think that's it, because I think that the story continues, honestly. So we're in 2004. Flash forward to 2010. The New York Times releases an article called "What Is It About 20-Somethings?" This talks about the new, strange way that the 20-somethings were living, this aimless stage of life that many of them were in. It's full of typical millennial-hating stuff, and the important thing to me is that it's right after the 2008 economic crisis, right? So we were having so many things go wrong then that the article is basically asking about why the youth are failing to launch in the midst of an economic crisis. And you know what else that article decides to do? It decides to ask a neuroscientist what was wrong with our youth. So who did they get for a quote in this piece? They asked, of course, our friend, Dr. Geed, and some members of his lab. And here's the quote. Among study subjects who enrolled as children, MRI scans have been done so far to only age 25, so the scientists have to make another logical supposition about what happens to the brain in the late 20s, the 30s, and beyond. Is it possible that the brain just keeps changing and pruning for years and years? Guessing from the shape of the growth curves we have, Geed's colleague, Philip Shaw, wrote in an email message, it does seem that much of the gray matter, where synaptic pruning takes place, seems to have completed its most dramatic structural change by age 25. For white matter, where insulation that helps impulses travel faster continues to form, it does look as if the curves are still going up, suggesting continued growth after age 25, he wrote, though at a slower rate than before. Despite that paragraph conveying, twice, that there's a lot of continuing growth possible after the age of 25, that paragraph does sure have the number 25 in it. A lot, doesn't it? By around 2014 or 2015, it seems like the myth had just fully been adapted into our collective consciousness. So my results for a Google search with the years limited from 2010 to 2015 show a Harvard Medical News article, the BBC, and NPR just repeating this 25 years factoid. And then hilariously at the bottom, there's a Quora user having doubts about it. So go you. Unfortunately, by 2013, this little factoid had even made its way into the scientific literature. So Arain et al. Concluded a paper with a note that the development and maturation of the prefrontal cortex occurs primarily during adolescence and is fully accomplished at the age of 25 years. The development of the prefrontal cortex is very important for complex behavioral performance, as this region of the brain helps accomplish executive brain functions. Also, as a side note, this paper is not my favorite. So its source for why adolescence ends at 24 and then brains are completely developed is a CDC article, which is talking about the sexual wellness of youth. And then it also refers to a book about the adolescent brain, which never mentions the number 25. So it's just lazy scholarship to me. So yeah, shame on that. That's not good. And of course, as we've already talked about, there's not a magic number where your brain is fully developed and done changing. Unfortunately, by 2016, we were starting to see some pushback against this idea. So Somerville asked in an article in Neuron, and it was called Searching for Signatures of Brain Maturity. What are we searching for? And it was basically talking about what actually would be associated with maturity in the brain, kind of pushing back on that idea that you're finished cooking at age 25. And so after that, really, in the pop culture, that brought me right back to that 2022 Slate article that I started with. So it was calling out the myth and wondering how it got started. Which means that, honestly, this seems to be a piece of science communication gone awry. There was a responsible scientist trying to communicate his ideas and research with the rest of the world, and we managed to oversimplify and misunderstand this fact, this incorrect fact. So that's how we got the myth. It was so close to being true. It was just entirely wrong. And I tried to find anything that Dr. Geed had said publicly about how his work had totally started this myth. I couldn't find anything. The closest I got, and in true burned by science journalists in the past, is just a straight up academic article written with some colleagues. But it talks about the promise and pitfalls of neuroscience research in health and law policy. And I think it's a great article. It calls to attention kind of the challenges of getting evidence, empirical evidence for brain structures that actually impact behavior. So that's an important link to measure there. It also talks about how we have this bias towards accepting neuroimaging data, even when it tells us less about the brain than we want it to. And then it goes into how we can have a better, clearer dialogue between researchers and law and policymakers. So yeah, it's a great article. I agree with the whole thing. So yeah, I think that's fantastic. Also, shout out to this article I found when searching to see whether Dr. Geed had said anything about it, because it was in IFL Science, and it just completely, fully identified the source of the myth to that original study, and then the article following it. So yeah, Francesca Benson, good job. So, my lovely friends who have listened to me rant for a while now, I think that's our story. A myth, an oversimplification of a scientist's hunch, ended up propagating itself straight into pop culture, where it was used to criticize everything from Leonardo DiCaprio's dating habits straight to the decisions of the youth themselves. And I could use that as a springboard to talk about the dangers of how easily science communication can get twisted. And I do think that talking to journalists who don't understand your research can sometimes be an unfortunate idea, but I don't think that's the whole story. I think it's not just a case of a scientist's words being twisted. I think it's a case of using science to explain a whole generation feeling like we're stuck in limbo. I think that the research was perfectly positioned in time, 2004, which was right before 2008. I think that we just latched onto this idea that young adults weren't really fully formed adults, because we were in a time when the traditional markers of adulthood seemed so far away for so many members of my generation and of millennials. When true adulthood feels out of reach, of course we're going to start reevaluating what it means to be an adult. And when you're rethinking what it means to be mature and an adult, and you have these pretty neuroscience pictures of the brain and all these fancy statistics to back you up, and you kind of think that a scientist said it somehow, it makes sense that we'd start telling ourselves that, oh no, the brain doesn't mature until 25, it's totally fine. And, the facts themselves don't really matter in this case because we're explaining what we already feel to be true. So what have we learned here? I think we learned that science communication can be tricky, and that if you hear a fact that just makes perfect sense and you incorporate that into your worldview, sometimes the fact isn't a fact at all, and it can warrant looking into further. I think that the real story tends to be a little bit more interesting, a little bit more exciting, and a little bit more complicated than the little factoids that we might hear. So I'll give you a challenge. Next time you hear one of those little factoids, just look it up, see if it's interesting at all, see if it's got a bit more of a complication than you think it does. And who knows, if it's interesting enough, maybe I'll do a little bit of a video on it. So thank you so much for watching this video. I had so much fun doing the research for it. Honestly, this rabbit hole was very entertaining for me. So if you enjoyed this, please don't forget to like and subscribe, and hopefully I'll see you next time. Okay.